Hi everyone, this is Srikanth, Assistant Professor of EE Department. In today's session, I'm going to discuss the problems on nodal analysis. Nodal analysis is a powerful technique used to calculate the nodal voltages by using Kirchhoff's current law. Let us go with some problems on nodal analysis. It's 8 ohms, 2 ohms, and 5 ohms. Now we need to calculate what is the voltage across 8 ohms VH by using the nodal analysis. So in order to calculate the voltage across 8 ohms by using nodal analysis, first we need to identify how many number of nodes are there. So the number of nodes are here. Node is nothing but interconnection point of more than 2 elements. This is the node 1, this is node 2, this is node 3. Here number of nodes are 3. Number of nodes we are having 3. Out of 3, one node will be a reference node, and that node will be always, we are going to take the node where we are having more number of connections, that will be taken as a reference node with a 0 volts, or generally we will take it as the lower part of the circuit will be a ground node, that is at 0 volts. Now the voltage will be having the magnitude, the assumption of voltage magnitude as V1 and V2. Now one more assumption we are going to take while writing the KCL at a particular node, that is all the currents are leaving from that node. All the currents are leaving from that particular node. So here when we are writing KCL, Kirchhoff's current law at node 1. Kirchhoff's current law at node 1. What is Kirchhoff's current law? Algebraic sum of currents at a node is equals to 0. So here all the currents we are assuming it as leaving from the node. So all the currents will be positive we are going to get. That is our assumption. While writing the equation, it will be easy if we assume like that. So KCL at node 1, here what is the current flowing through 4 ohms? Here we are having V1 voltage, on the other side we are having 10 volts. So the what is the resultant voltage? V1 minus 10. So V1 minus 10 by 4 plus, here the voltage is V1 and here the voltage is 0 volts. V1 minus 0 by 6 plus here we are having V1, here we are having V2 is the voltage. So V1 minus V2 by 8, which is equals to 0. So here If we take V1 common, 1 by 4 plus 1 by 6 plus 1 by 8 minus V2 by 8 is equals to 10 by 4. This is our equation number 1. This is KCL at node 1. Now KCL at node 2. KCL at node 2. Here, when we are writing the KCL at node 2, again all the currents are leaving from the node. So here current flowing through 8 ohms is V2 minus V1 by 8. V2 minus V1 by 8 plus V2 by 2 plus V2 minus 4 by 5, which is equals to 0. If we take here minus V1 by 8 plus V2 into 1 by 8 plus 1 by 2 plus 1 by 5, which is equals to 4 by 5. This is our equation number 2. By solving these two equations, by solving equation 1 and equation 2, equation 1 and equation 2, we'll get the V1 and V2. 5.01 volts, 1.72 volts. These are the voltage values at node 1 and node 2. We need to calculate the voltage across 8 ohms with this terminal as positive. So that is V1 minus V2, which is equals to 5.01 minus 1.72. 5.01 minus 1.72, that is 3.29 volts. So here we got the voltage across 8 ohms as 3.29 volts. Now let us go with the current source. Six amperes, 4 ohms, 2 ohms, 10 ohms, 8 ohms. This is, let us consider this as 5 ohms. Now we got this is the circuit which is given with one current source and voltage source. Here first we need to identify the number of nodes and give the magnitudes and also give the reference node. So here this is our node 1. Let us consider this node 1 voltage as V1, this node 1 voltage as V2, and this node voltage let us consider it as 0 volts. Now let us write KCL at node 1. KCL at node 1. Here we have to assume that all the currents are leaving from the node. Here, the current flowing through the 6 amperes is in the opposite direction of our assumed direction. So we have to take it as minus 6 plus V1 by 4 plus V1 minus V2 by 2 is equals to 0. Here if you take V1 common, 1 by 4 plus 1 by 2 minus V2 by 2 is equals to 6. That is equals to V1 into 0.75 minus V2 into 0.5 plus, sorry, equals to 6. This is our equation number 1. Now KCL at node 2. KCL at node 2, that is V2 minus V1 by 2 plus V2 by 10 plus V2 minus 5 by 8, which is equals to 0. That is minus V1 by 2 plus V2 into 1 by 2 plus 1 by 10 plus 1 by 8, which is equals to 5 by 8. Here, this is our equation number 2. By solving equations 1 and 2, by solving equations 1 and 2, we'll get V1 and V2. 15.87 volts, 11.8 volts. This is the V1 and V2 values. Now, if we want to calculate the voltage across 2 ohms, V2 ohms, voltage across 2 ohms is equals to, here it is given this terminal as positive. So that is V1 minus V2, 15.87 minus 11.8. That is equals to 4.07 volts. This is the way we need to calculate the voltages across the nodes by using Kirchhoff's current law. Now we'll go with the other problem. Different problems let us discuss. Ten amperes, 4 volts, 2 ohms, 4 ohms, 6 ohms, 3 ohms, 5 ohms. This is the another circuit with one current source and another voltage source, which is having different node connections, which all the nodes are connected to all the other terminals of the nodes. Here we are going to get, in all the equations we'll get all the nodal voltages. That is the different case in this. Here this is the node 1 voltage V1, node 2 V2, node 3 V3, and this is at 0 volts. Now let us write the KCL at node 1. KCL at node 1. That is, here all the currents are, we are assuming that they are leaving from the node, but here 10 amps current is coming towards the node. So we have to write it as minus 10 plus, here current flowing through 3 ohms is V1 minus V2 by 3. V1 minus V2 by 3 plus current flowing through 5 ohms is V1 minus V3 by 5. V1 minus V3 by 5 is equals to 0. Here if we take V1 common, 1 by 3 plus 1 by 5 minus V2 by 3 minus V3 by 5, which is equals to 0. This is our equation number 1. Now let us write the KCL at node 2. KCL at node 2, that is, all the currents are leaving from the node. So here V2 minus V1 by 3, that is current flowing through 3 ohms resistance, and V2 by 2 plus V2 minus V3 by 6 is equals to 0. Here minus V1 by 3 plus V2 into 1 by 3 plus 1 by 2 plus 1 by 6 minus V3 by 6 equals to 0. This is our equation number 2. Now KCL at node 3. Now current flowing through 6 ohms is V3 minus V2 by 6 plus V3 minus V1 by 5 plus V3 minus, here it is 10 volts, sorry 10 amperes, V3 minus 4 by 4, which is equals to 0. Here if we take minus V1 by 5 minus V2 by 6 plus V3 into 1 by 6 plus 1 by 5 plus 1 by 4 is equals to 4 by 4, 1. This is our equation number 3. Now we have got the 3 equations. By solving these 3, by solving equations 1, 2 and 3. By solving equations 1, 2 and 3, we are going to get the V1, V2 and V3. Now we got the V1 value as 33.51, V2 value as 13.87 and V3 value as 16.24 by solving equations 1, 2 and 3. Now it is asked to calculate what is the voltage across 5 ohms. Voltage across 5 ohms, if this is the positive value, so that is equals to V1 minus V3, that is 33.51 minus 13.87 volts, that is equals to 19.36 volts. This is the way we can calculate when we are having one current source with 3 nodal voltages. Now let us go with another problem. The same 3 nodal equations, but the connection is different. 20 amperes, 4 volts, 6 volts, 2 ohms, 4 ohms, 6 ohms, 8 ohms, 10 ohms, 12 ohms. Let us take the only even values so that we can have the easy calculations. And here we are having 4 number of nodes. This is V1, V2, V3, and this is our reference node. Now we need to write the KCLs in different KCLs at different nodal. Let us write the Kirchhoff's current law in all the 3 nodes. Here KCL at node 1. KCL at node 1, that is current is in the reverse direction of our assumed direction, so minus 20 plus V1 minus 4 by 2 plus V1 minus V2 by 4 plus V2. Right. Only 3 currents are there, which is equals to 0. Here if we take V1 common, 1 by 2 plus 1 by 4 minus V2 by 4 is equals to 20. This is our equation number 1. Now KCL at node 2. Here these are the currents which we need to write. Current flowing through 4 ohms is V2 minus current flowing through 4 ohms is V2 minus V1 by 4 plus V2 by 6 plus V2 by V2 minus V3 by 8 is equals to 0. Here it is minus V1 by 4 plus V2 into 1 by 4 plus 1 by 6 plus 1 by 8 is equals to 0. This is our equation number 2. Here V1 minus 4 by 2, that is 20 plus 2, 22, which we need to write here. 20 plus 2, 22. This is our equation number 1. Now let us write the KCL at node 3, that is V3 minus V2 by 8 plus V3 by 10 plus V3 minus 6 by 12 is equals to 0. That is minus V2 by 8 plus V3 into 1 by 8 plus 1 by 10 plus 1 by 12 equals to 6 by 12. This is our equation number 3. Now by solving equations 1, 2 and 3, we'll get the V1, V2 and V3 values. 34.6 volts, 16 volts, 8.1 volts. These are the different nodal voltages. The next one is, let us go with one more problem on this nodal analysis. With the number of current source, let us consider. Here 20 amperes, 2 amperes, 3 amperes, 4 volts, 3 ohms, 6 ohms, 2 ohms, and 4 ohms. This is our circuit which is given. Now we need to calculate the nodal voltages. This is the node 1 voltage V1, V2, V3, and this is at 0 volts. Now KCL at node 1, that is minus 20 plus V1 minus 4 by 3 plus V1 minus V2 by 6 is equals to 0. That is, if we take V1 common, 1 by 3 plus 1 by 6 minus V2 by 6 is equals to 20 plus 4 by 3. This is our equation number 1. This is KCL at node 1. Now the KCL at node 2. KCL at node 2, that is here V2 minus V1 by 6 minus 2 plus V2 minus V3 by 2 is equals to 0. Here it is minus V1 by 6 plus V2 into 1 by 2 plus 1 by 6 minus V3 by 2 is equals to 2. This is our equation number 2. Minus V1 by 6 plus V2 into 1 by 2 plus 1 by 6 minus V3 by 2 is equals to 2. This is our second equation. Now the KCL at node 3, that is V3 minus V2 by 2 plus V3 by 4 minus 3 is equals to 0. That is minus V2 by 2 plus V3 into 1 by 2 plus 1 by 4 is equals to 3. This is our equation number 3. By solving equations 1, 2 and 3. 1, 2 and 3. You get the V1 value, V2 value and V3 value. 56 volts, 40 volts, 30.66 volts. These are the V1, V2, V3 values. With these values, we can calculate any parameter in the circuit, like current flowing through a particular element or voltage across a particular element. All these can be calculated by using these nodal voltages. In this session, we have discussed several problems on nodal analysis and how to calculate the voltage across a particular element by using nodal analysis also discussed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.